Good morning, guys. Hopefully everybody's doing okay. If you could give me some green check marks, please let me know you're with me. And we will start right into Unit 4, Lesson 2/3. We're going to do them together. And good news about this section is we've already covered this stuff because it was actually in the radicals unit. And it's a bit of a repeat, so there you go. We do have a new student in today, Josh. He was in Blackboard the other day, but can't get to the live feed. So I'm just going to see if I can get him connected to the live feed, and then we'll get going. If you do have any questions you want to throw them into chat, you can do that. And we'll see if he can get in. I got a new computer as well, and obviously you can see it behind me here, but I must admit that I don't know how to use it yet. It's Windows 10. I'm a Windows 7 kind of guy. So if I'm kind of like floundering around trying to find things, it's just because I'm trying to learn as I go. But I thought, hey, let's give it a shot and see if we can get it going. Nora's Jesse, Ian's in. Just want to make sure we can get Josh in, and then we'll get going. While we're waiting, if you haven't given me a green check mark, you want to do that, just so I can make sure we're all doing okay, and then give Josh a second or two, and then we'll just start. So the majority of the stuff we're going to cover today is actually things that you've looked at before, whether it be in grade 9 or in the radicals unit. We looked at expanding, feeding the chickens, FOIL, these sorts of things. Thanks for the green checks, guys. So we will just continue through it, and it's a nice, easy way to kind of ease into this next couple of sections. The Unit 4 material, it starts really straightforward, and then it gets into something called factoring. And students hear the word factoring and they get all scared. It's really easy. There's just one sort of process you need to learn how to do, and once you've done that, you can do all of the questions. So let's jump into this. This says expand, so there's going to be a couple different types of questions in this unit. You're going to see questions that say expand, and that'll be the questions we look at today. And then there'll be questions that say factor. And expanding and factoring are just opposites of one another. And we'll look at that and how that works. So for today, we're going to do expanding, because we're doing expanding polynomials. And then I believe tomorrow we start factoring. So when we're expanding, we talked a little bit about feeding the chickens. So when you have something outside of the brackets and a bunch of stuff inside of the brackets, everything inside of the brackets needs to get multiplied by whatever's outside of the brackets. You don't want to not feed any of the chickens. So when I'm multiplying 3x by everything in this bracket here, I need to multiply by each of the terms inside the bracket. And if I forget one of them, bad things happen. So the first one's going to be 3 times 2, which is going to give me 6. And then I have x times x squared. Now, we spent a lot of time talking about what to do with exponents. And if we're multiplying exponents with the same base, we add the exponents. So it's going to give me 6x to the power of 3. And then I'm going to go 3 times 5 is going to give me negative 15. And x times x is going to give me x squared. And then 3x times positive 2. Oh my goodness, touch screen needs to be shut off. 3x times 2 is going to give me 6x. So I've multiplied the 3x through everything inside of the brackets. And once I get to this point, I can combine any like terms I have. In this particular example, I don't have any like terms. So they're all different exponents, different degrees. So I have x cubed, x squared, and x. So I can't really do anything beyond that. So that kind of is it. Pretty straightforward. This next question, letter B here, we have a few things going on. I have a number in front of my brackets, so I have this 4 here. I'm going to have to multiply that by both things inside my brackets. Then I have nothing here, but it acts kind of like a -1, so I need to multiply that by both things inside my brackets. And I essentially want to follow the rules of BEDMAS. But in this case, I don't really have anything to do inside of my brackets. So inside of each of those brackets, there's nothing further to simplify. So all I need to do then is move on to exponents. I don't have any exponents. Okay, multiplication. I'm going to multiply this 4 through the brackets. So I'm going to get 4 times 2 is 8x, and 4 times -1 is -4. So that's my first step. I also need to do the multiplication here. Even though there's nothing here, I'm going to multiply a -1 through there. So I'm going to get positive 4x and -2. All right. At this point, I need to ask, are there any like terms? So I have 8x and I have a 4x. I can combine those together because those are both x's. And then I have a -4 and a -2, which I can combine together. So 8 and 4 gives me 12x, and -4 and -2 gives me -6. All right, so that used the distributive property, meaning we have to multiply everything inside the brackets by everything out front. That was kind of a basic way of looking at these types of questions. We'll get ones that are a little bit trickier, so we'll look at these next two. Where you're going to use the same distributive principle, but instead of there being one thing in front of the bracket, think of it kind of as there being two things. And we used a little bit of an acronym in the radicals unit. We used FOIL. And we're going to use that again. So remember the F for FOIL is first. Then we have outside, because I don't need two O's. Inside, and last. So essentially we're making sure that each term in the first bracket gets multiplied by each term in the second bracket. Everything needs to get multiplied by everything else. So FOIL starts with first. So I'm going to multiply the first term by the first term. I'm going to get 2x cubed times x is giving me 2x to the fourth. Oh boy. Next I'm going to do my outside terms. So 2x cubed times -5. 2 times 5 is going to give me -10 x cubed. And then I have my inside two terms. 3 times x. I think I've had about enough of my new computer. 3x, and then 3 times -5 is going to give me -15 for my lasts. So the 3 times the -5. almost every time we FOIL, we're going to have to combine some like terms. This one worked out that there was no like terms to combine, but generally speaking, you will have like terms that you have to combine together. So there you go. Letter B is the exact same process, except instead of there being two terms or in each of the brackets are binomials, we have a binomial and a trinomial, but the same principle applies. We need to multiply everything in the first bracket by everything in the second bracket. So what's that going to look like? Well, I'm going to have to multiply the 3k by the k squared, by the minus 2k, and by the minus 7. And then I'm going to have to multiply this 4 by this k squared, by the minus 2k, and by the minus 7. So I'm going to end up with 3 terms from my 3k multiplying by those 3 things, and then another 3 terms when I multiply my 4 through. So I'm going to end up with 6 things, and then I'm going to have to combine any like terms I have. All right, so 3k times k squared is going to give me 3k cubed. 3k times negative 2k give me negative 6k squared. And 3k times negative 7 is going to give me negative 21k. All right, now I'm going to do the second. I'm going to do my 4 times everything in the second bracket. So 4 times k squared is going to give me positive 4k squared. 4 times negative 2 is going to give me negative 8k. And 4 times negative 7 is going to give me negative 28. Okay, now I need to combine like terms. Let's see what I got here. K cubed, I only have one of those. I have some k squareds here and another few k squareds. What else do I have? I have 21k and 8k. And I think those are the only things I can combine. So I'm going to just bring down this 3k cubed. It's going to come along. Then the things in yellow. Negative 6k squared plus 4 is going to give me negative 2k squared. Negative 21 minus 8 is going to give me negative 29k. And then I'm just going to bring down the negative 28. Now I have k cubed, k squared, k, and then just the integer 28, so I can't combine anything further there. How are we doing so far? I mean, this is the second time you've seen this stuff, but a little bit more complex. Does anybody have any questions at all? Questions, questions, questions. Anything you're unsure of? Thanks, leads. Didn't get. Looking weird. Don't understand. Cool, Jesse. Thank you, Eric. All right. We'll just keep going then. It looks like I added some additional questions in last time. They kind of got blocked out. Let's put in a letter C here, might as well. Let's go like this, 3 minus 2x cubed times 8x squared. What happens when the term is behind the bracket? Does that change how we do things, or is it just the exact same process? Is anything different? Well, all we need to do is the exact same thing, except we're kind of working backwards now. Doesn't really matter how you think about it. As long as each term in the brackets gets multiplied by the thing that's outside of the bracket, you'll be doing okay. All right, so 8 times, we'll go 8 times 3, or 8x squared times 3 is going to give us 24x squared. And then 8 times 2 is going to give me negative 16. X cubed times x squared, x to the 5. There's a little note here. You can always do this to kind of check your answer. One way to check that a product is likely correct is to substitute a number for the variable into the original expression and the product. So let's try that. Remember, what you start with and what you end with are the same thing. So that's what I ended with, or what I started with, I should say. And then 24x squared minus 16x to the 5th. That's what I ended with. So both of these things should be equal. Now, I can pick any value I want to substitute in just as a check. So I can pick 0, I can pick 1. In this case, 0 is going to not really reveal a lot. So let's just go with x equals 1. We're going to substitute x equals 1 into the brackets, anywhere there's an x. So 3 times negative 2 times 1 cubed, 8 times 1 squared. I pick 1 because 1's a really easy number to deal with. I could have picked anything. I could have picked 72 if I wanted, but that would have been a little bit confusing and a lot of sort of math. And if we can pick whatever number we want, we might as well pick something really easy. All right, so 3 times 1 cubed times 2, if I do my exponents first, what I'm going to end up with in the blue here is 3 times, that's going to be 2, and then outside of my brackets I have 8. Three minus 2 is going to give me 1, and 1 times 8 gives me 8. So I started with 8. I should also end up with 8 on the other side here. So let's do the red now. 24 times 1 squared is going to give me 24 minus 16, and that gives me 8 as well. So if you are unsure, you can always just put in a number into both the original equation and your answer and see if you get the same number. We get 8 and 8, so we know that we got the answer right. I won't ask you guys to check very often. If you want to, just know that you can do that, and it should work out for you. All right. Up above here, on the right in letter B, we did a binomial times a trinomial. So 2 things in the first bracket, 3 things in the second. Number 2 is asking us to expand, so we're going to multiply. That's what expand means. And then simplify. Except we have 2 trinomials. Oh no. What are we going to do? Well, the same principle applies here. We need to make sure every term in the first bracket gets multiplied by every term in the second bracket. There's nothing terribly difficult about this. We're just going to end up with a bunch of terms because we're going to get that first term times 3 things. So there's 3. The second term times another 3 is another 3, so 6. We're going to end up with 9 terms. And then we're going to have to combine our like terms and see what we end up with. So I guess maybe I'll pick a couple different colors here. I'll do the 2t squared in red. So I'm going to multiply this 2t squared by each of these three things. Maybe we'll do the next one in blue. I'm going to be this 4t times the next 3. And then the last one we'll do in green, this 3 times each of these things. So each term in the first set of brackets needs to be multiplied by each term in the second set of brackets. Nothing new, just a little bit more complicated. All right, do a little warm up here. Let's go. Negative 2t squared times 5t squared. So I'm starting at the beginning. It's going to give me negative 10. T squared times t squared is t to the 4. You know what? I'm going to move this all over to the left a little bit. I'm probably going to run out of room. Negative 10 t to the 4. So there's my first one. Now negative 2t squared times negative 2t. It's going to give me positive 4. T squared times t is going to give me t cubed. And negative 2t times negative 1, no, positive 1. Negative 2t squared times positive 1 is going to give me negative 2t squared. All right, so there's my first term, negative 2t squared times each thing in the second set of brackets. Now I'm going to go to my middle term in my first set, the 4t, the blue one here. I'm going to multiply the blue one by everything in the second set of brackets. So 4t times 5t is going to give us positive 20t cubed. 4t times negative 2t is going to give us negative 8t squared. And 4t times positive 1 is going to give us positive 4t. And then I'm going to take this last term, the negative 3, the one in green, I'm going to multiply it by each thing in the second bracket. So negative 3 times positive 5t squared, negative 15t squared. I'm going to have positive 6t and negative 3. Okay. Almost ran out of room. Saved it. That's a good thing. Okay, now I need to combine my like terms. So anything that's the same in terms of an exponent. I can't combine t fourths and t squareds. It just doesn't work. I have to combine like terms. So what do I have? What's similar? Okay, t cubes. Do I have some t cubes? I do. I have this positive 4t cubed. And then I have this positive 20t cubed. T squareds, I have negative 2, I have another negative 8, and a negative 15. And then t's, I have 4, and I have 6. So I'm going to combine those. My negative 4t squared, or t to the 4th to start, and my minus 3 at the very end, they're kind of just lonely. They have no friends to combine with. So I'm just going to bring it down. So negative 10 t to the 4th. Nothing I can do there. Now my t cubes in the boxes. 4 plus 20 is going to give me 24 of them. Negative 2t squared and negative 8t squared and positive, or minus 15. So negative 2, negative 8 is negative 10, minus 15 is negative 25t squared. My t's, I have 4 and another 6. Nope, 4 and 6 is 10, not 6. And then minus 3. All right. That's it. I can't combine anything beyond that. It just, that's as simple as it gets. It doesn't look very simple, but that's as much as we can do. You'll find the questions in the learning guide. They all work out quite nicely, so you never really end up with really messy things like this. Just kind of worked out that way for this guy. The next question is the exact same as one that we've done up above, but we have more than one variable. So every question up to this point, you've had an x or a t or whatever, just one variable. This question has v's and w's. Does anything change? No. The multiplication stays the same. We still have to multiply each term in the first bracket by each term in the second bracket, except we have two variables. So when we go to combine our like terms at the end, we have to make sure that both our w's and our v's are the same before we can combine them. I'll show you what that looks like. I have a feeling most of you could probably do this without my help. We're going to multiply each term in the first bracket by each term in the second bracket. And we're going to combine our like terms if there are any. 2v times 3v is going to give us 6v squared. 2v times positive 2w is going to give us positive 4vw. And 2 times 7 is going to give us negative 14v. All right. Now the second term, negative 5 and the 3 is going to give us negative 15vw. Negative 5 times positive 2 is going to give us negative 10. ww is w squared. And negative 5 times negative 7 is positive 35. W times nothing is w. Now I look at my variables. Do I have any that are the same? I do actually. I have 4 VWs and I have minus 15 VWs. Everything else is different. And I guess the only kind of tricky thing left would be, what order do we write these in? Normally we start with like a t cubed, and then we go t squared, and then we go t. We kind of go in descending order of exponents. What do we do here? Well, you're going to see it written many different ways. Sometimes you'll have the w squared and the v squared on either ends because it makes more sense for when we get to factoring. Sometimes you'll see the v squared, then the w squared, then the v, then the w. If you do it in kind of descending exponent and alphabetical order, it doesn't really matter. What I'm going to do is this. I'm going to go 6v squared. I'm just going to rewrite it. Let's go minus 10w squared. So start with my biggest exponents. And then my vw comes next. So positive 4 minus 15, combining the ones in the highlighting, gives me negative 11. Negative 11 vw. What do I have left? I have negative 14v and 35w. So generally speaking, that is the way that the learning guide will write these things. Just be aware if you get to the end and you're like, wonder what the answer is, and you check, everything's kind of the same but just in a different order, you're still right. You can put in whatever order you want. It doesn't have any effect on the question. Okay, there's a couple more to go here. What do we have left? 3 more. So question 4 is kind of combining a couple ideas together. We have this, the distributive principle where we multiply each term in the brackets by each term in the next bracket. And then we have this distributive principle again with the minus sign. We have a squared in here. What does that mean? We're just going to mix a bunch of stuff together that you probably could do on their own, and then we'll see how we can combine these like terms at the end. So let's think about it in terms of this. What I'm going to do is I'm going to leave this question for now. I'm going to come back to it. So we're going to just make letter B down below here. And we have done this before. Oh my gosh. No, don't want the weather. Where are we? No, please stop. Please, no more. Okay. 4k minus 3k squared. Let's do that. Ian, yeah, it's not necessarily Windows 10. It's that normally when you get a tablet, I always use the pen. Some people like to use the touch screen because that's kind of fun. But I have a stylus, so when I put my hand down to write, it thinks I'm touching this bottom bar, and then it does that. So I need to turn the touch screen off. I don't know how to do that yet. So I just want to be able to use my little pen here. I'll get there. It's a learning process. All right, so I have this 4k minus 3k, and it's squared. Now, if I wrote something like x squared, you'd say, okay, that's x times x. A really common mistake students are going to make is they're going to take this exponent and give it to everything inside the brackets. And you're going to say, Mr. Borden, you told us to do that in the last unit. Why are we not doing that now? Well, in the last unit, we didn't really have anything, we didn't have binomials that were being added or subtracted. We had just things inside the bracket. They weren't being added and subtracted. So the reason we can't just give the exponent to everything inside the brackets is if there's addition or subtraction inside the brackets, it doesn't work that way. And it is one of the most common math mistakes students will make from grades 10 up through even into university. It's really common for students to make that mistake. So if you have something that's squared, you need to write it out twice. And that turns this question into a question that we've already done. 4k minus 3k times 4k, not x. So I've just written it out twice. It's funny that you guys say just Google it. I will actually have to Google it. I'll just probably dig around in the settings. This morning my wife was using our laptop at home and she's trying to get the @ symbol in to write her email address. And the keyboard had changed. It had like the alternate characters, the ones that are up on the top of the keys. She couldn't get the @ and I'm like, oh, let me see. And I tried to figure it out. And I couldn't. I literally couldn't. So as I was leaving for work, I said, Google it. And then I left. So I'm with you guys on that. Hopefully she Googled it. Or she's maybe still sitting there staring at her computer trying to figure out how to use it. So we have two things, two binomials. We're going to FOIL them. First, outside, inside, last. I like FOIL. It's a great acronym if you have binomials. Yeah, Ian, generally speaking, people don't like change, especially computer users. Change is always bad. I mean, there's probably some great things with Windows 10 that I just haven't got to know yet. This is my first Windows 10 experience. All right, FOIL. First, it's 4 and 4 is 16. 16k times k is k squared. And then 4k times the negative 3k is going to give us not positive 12, but minus 12. Minus 12, k times k is k squared. All right, now the blue, the second guy here, the inside. 3k is negative times 4k. It's going to give me negative 12k squared. And negative 3 times negative 3 is going to give me plus 9k squared. Now, just kind of something dawned on me. I'll just keep going, but There's actually a typo in the beginning here, but it doesn't really much matter. We can still do it this way. It just ended up being a lot of work that we didn't have to do. There should probably be like a squared or something here, because if we had 4k minus 3k, that's just 1k, and 1k squared is just going to be k squared. So if all of this adds up correctly, we should end up with k squared. Let's see, 16 minus 12, and 9. We have all k squareds. 16 minus 12 is going to give us 2, minus 12 is going to give you 10, plus 9. Yeah, we end up with 1k squared, which is the same thing as we would have had if we went 4k minus 3k squared. Oh, 4 minus 3? Oh, that's just 1k squared. Mr. Borden, use your brain, man. Oops. Oh, well. Trying to think of a way I can salvage this question. I'm not sure if there is one. Might have to just carry on. Yeah, I'm just going to carry on. We're going to move on. The combination of my touch screen computer and that. Yeah, we're just going to go. Keep going. Do we want to do 4 now? No, we don't. No, we don't need to do that. Let's do these last 2. They're a little bit more fun. We've already done a squared, so let's change this. I'm going to up this to a 3. But Mr. Borden, something cubed? Yes, something cubed. We're going to live life on the edge today. All right, 3x squared minus 2 times 3x squared minus 2 times 3x squared minus 2. That's what something cubed means. Just like if I had something squared, I would have written it out twice, and I would have went and figured it out. I have this thing 3 times. What do? Doesn't really matter. I can multiply the first one by the second one, and then multiply all that by the third one, and that's probably what I'm going to do. So I'm going to multiply my first 2 binomials together. I'm going to end up with a trinomial most likely, and then I'm going to multiply that trinomial by the binomial, and we'll see where we end up. Let's just go for it. All right, so I'm going to just kind of ignore this last guy for now. I'm just going to drop it down. So what I'm going to do is I'm going to FOIL my first 2. So 3x squared times 3x squared is 9x to the 4. And then 3x squared times negative 2 is negative 6x squared. My inside, I'm going to end up with another inside, negative 6x squared, and my last is going to give me a plus 4. I'm going to bring this 3x squared minus 2 along for the ride, and I'll just put all this stuff in brackets so I don't forget that I'm multiplying, but I do need to combine my like terms still. All right, so 9x to the 4. Nothing to combine that with. Negative 6 and negative 6 give me negative 12x squared and plus 4. All right. So I've multiplied the first 2 binomials together, and then I've done a little simplification. And now I have a trinomial times a binomial, which we've done before. So we need to make sure each term in the first gets multiplied by each term in the last. Let's pick a couple different colors so we can try to keep things straight. So I'm going to go the 9 times the 3, the 9 times the 2. And I'm going to go this 12 times the 3, the 12 times the 2. And then I'm going to go this 4 times this 3 and the 4 times the 2. And we'll see what we end up with. So let's start with red. 9 times 3 is going to give me 27. X 4 times x squared is going to give me x6. And then 9 times the 2 is going to give me negative 18x to the 4. So there's my 9x fourth times everything in the second bracket. Negative 12x squared times 3. So I'm going to get negative 36x x to the 4, and then positive 24 x squared. So those are my two terms there. And then 4 times, my last one in green here, 4 times 3 is going to give me 12 x squared, and 4 times 2 is going to give me negative 8. So there you go. Each term in the first bracket by each term in the second bracket. Tried to pick different colors. The last thing I need to do is combine any like terms I have. So it looks like I have a couple x fourths and a couple x squareds. So there's an x fourth, x squared. And then this 27, x to the 6, just going to come along for the ride. Negative 18 and negative 36. Get that right? Negative 18, negative 36. Sorry, I have something else written down on my sheet here, and I just want to make sure I did that correctly. 9 times that, 12. 1840, 54. All right, we're going for it. Negative 54 x to the 4. And then 24 and 12 is going to give me positive 36 x squareds. And then I have minus 8. I feel like there's something wrong there, but I'm thinking it's right. Does anybody else get anything different than that? Especially with the x fourths. I'm looking at it. 1836. 9 and 3 is 27. 9 and 2 is 18. All right. We'll just go with it. We have one more question left here, and definitely have some time to kill. So this last one's special, and you wouldn't be able to recognize it yet, but when we get a little bit further into Math 10, this type of problem is something we'll actually use to help us simplify things. And 2x plus 5 and 2x minus 5, you don't need to know this or even need to write it down, but these are called conjugates. And something special happens when we multiply conjugates together. And well, let's just multiply these two things and figure out what that is. So we're going to FOIL them, two binomials. First outside, inside, last. So 2x times 2x is 4x squared. 2x times minus 5 is negative 10x. We get positive 10x minus 25. So my first, my outside, my insides, and my last 4 terms. You'll notice my middle 2 terms. This is what's special about these. These middle 2 terms actually cancel out. So we end up with 4x squared minus 25. Plus 10x and minus 10x just go to 0. We'll call this difference of squares. We'll use the conjugate to simplify denominators. We'll use the fact that if we have the same 2 things inside our brackets, the same binomials, and they have different signs, that it kind of cancels things out. So we'll use that fact a lot. Not a lot. We'll use it from time to time. All right. So that's it for the lesson. Nothing terribly difficult. I shouldn't say that. It's tricky. It's a lot of work, but stuff that you've definitely done before. So, Polynomials Learning Guide, we've done this, we've done this, we've done that. That was November 10th. So you were, last day I left you with the first page in a bit, and I said, okay, if you get to it, great. If not, worry about the Unit 3 test. And I think I've got about half of you have done the Unit 3 test. The other half have not. That was hopefully to be done by today. If you haven't done it, get it done. submit your learning guide, and I will get you the password as soon as I possibly can. So what do we have for today's kind of work? So starting from November 10th here, looking at the learning guide, page 2, you should be able to do question 1. You should be able to do question 2. You should be able to do expanding. And these are just kind of area problems. So you should be able to do up to the bottom of page 5. Today's the 15th, November 15th. So everything up to algebra tiles. Oh, algebra tiles. I dislike algebra tiles more than you can imagine, but we have to talk about it. So we will eventually. So there you go. The first 5 pages of the learning guide should be done for Thursday's class. We do have some time. So does anybody have any questions from Unit 3? If you're done the Unit 3 tests, then you can just kind of ignore me for a few minutes here. Any questions from Unit 3 at all? Anything that you wanted to get out of the way before you finish the learning guide or the test? Nothing. All right. Maybe I will give you guys some time to work through this stuff. And we do have a lot of time here because we didn't have a bunch of questions at the beginning of class. So what we'll do, maybe put up 15 minutes on the timer. And I'll let you guys work through this stuff for 15 minutes. And if you guys come back with some questions, we can spend the last sort of 15 minutes working on those questions. But if not, at the end of 15 minutes, if nobody has any questions, then you guys can just continue to work or log out. What about number 4? Number 4. Like on the first page, Eric, or are we talking about a different page? Maybe throw in a page number, at least the section. I know page numbers sometimes look different depending on how yours formats and prints. There's likely a few number 4s. This is the Unit 4 learning guide, Eric, but I have a number 4 on the first page. And I have a number 4 on page 5. So help me out. Page 1 or page 5, Eric? What is the question referring to? Is it referring to write 3 different terms that are like? Well, we can do it, man. We've got time. All right. I'm never going to mind. I won't mind. All right, so we're going to put 15 minutes up. See you guys back in 15 with some questions. Thanks. All right, guys, you had 15 minutes kind of mull things over, see how Unit 4 is going in terms of learning guide. Did anybody run into any issues, questions, problems that they want me to go through for the first 5 pages of Unit 4? Anything you didn't understand? Eric, did we get anywhere on number 4, the mythical number 4? And then I still haven't, I don't know, Josh, I've been typing to you in Blackboard. And I just want to make sure you're in, Josh, but maybe I'll just talk to you. You meant on the other thing, like the lesson. This number 4 here, Eric. I get what you're saying. No, we're not going to do it because it's not worth it. Sorry, I apologize I was on the learning guide. We'll just cross it out. I said I'd come back to it, but I don't want to come back to it. Get rid of it. Oh, Josh, you did time me back. Cool. No, good, Josh. I'm glad you're in and you have the chat up. It's good. Josh, I did send you a message in Moodle. I don't know if you got it. I just have the some stuff printed off for you. So check your email or messages and we'll figure out a time when we can get together. All right, Leeds asks D on page 3. Do I have to do it quickly or can I take my time with it? A, B, C, D. All right, simplify. This is kind of looking like an exponents question from the last unit, hey? Where you have this exponent outside the brackets and stuff inside. But it's actually probably a little bit easier because there's no negative exponents. You have no fractional exponents or anything like that. I'm assuming this is the one you're referring to, Leeds. Did I get that right? This guy here, before I attempt to do it quickly, as per your request. Okay. All right, so just following BEDMAS. Anything to do inside the brackets? Nope. I go into exponents. I'm going to just kind of maybe do this over here, run out of room. So everything inside the brackets is going to get this squared, x squared. It's going to give me x 2 times 2, y 3 times 2. I probably wouldn't show this step for the numerator there, but you can see it. So, all right, 4 times 4 is going to give us 16. X to 2 times 2 is 4. Y is 6. And then 8x cubed y cubed. Now, if we were in the exponents section, I would likely subtract my exponents top and bottom, and I kind of like to think of it that way. Because we're in the kind of polynomial section, I deal with these things a little bit differently. And whether you like the way I deal with it or not, it doesn't matter. You can do it this way I'm about to show you, or you can do it the way that we did it in the last unit. But when I see that I have an x to the 4th and an x cubed, like top and bottom, I say, well, I have 4 x's on the top and I have 3 on the bottom. So what am I going to be left with? I'm going to be left with 1 x on the top. So what I do is I kind of cross off this whole thing, and then with the exponent, I just put a little 1 next to it. And then I do the same thing here. I have 6 y's on the top and 3 on the bottom, so I'm going to be left with 3 on the top. And then 16 and 8. Well, I can divide 16 by 8 and get 2. I can divide 8 by 8 and get 1. So I just kind of go through it like this and simplify things along the way. It gets kind of messy, but it's just kind of the way I like to do these things. So what do I have on the top? What's left? Well, I have this 2, and then I have 1x. Then I have y cubed. And on the bottom, I just have a 1, and that's it. Just 3 1s, essentially. So I don't really need to do anything further there. I could alternatively write it like this. Think about it this way. 16x to the 4 is like x, 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 x. 1, 2, 3, 4, 5, 6 y's. And then 8, 1, 2, 3. 1, 2, 3. I could write it like that. That's a lot of work, but I could do it that way. All right, so this x divided by this x gives me 1. This x divided by this x gives me 1. This one divided by that one gives me 1. And I'm left with this. Y, 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 y. I'm left with these 3. So that's kind of what I'm doing kind of in my head as I go through it. But if it doesn't work that way for you, you want to actually do like the subtraction, that's fine as well. There's lots of ways to do these questions. Does that help you out, Leeds, a little bit, I hope? Any further questions there, Leeds? Why to the 5th? Thank you, Eric. That's 5 there. Let's just erase all of this. Redo that. So instead of a 3, what do I have? 6 and 5 is going to give me a 1. So I'm just going to have a y. Add a couple y's down here. 4, 5. There we go. Gotta love it when you ask a question and your teacher does it wrong. Jeez. It's just not my day today. There you go. Does anybody have any further questions from this stuff? Unit 4. All right, we'll just take a little peek. Oh, I don't know if I can. You know what I'm going to do? I'm going to get out a little tablet mode here and yes, definitely want to exit tablet mode. Let's just take a little gander into the course and see what we have left here. So we just did simplifying polynomials, we've done expanding, and expanding special. So we've done the first 3 sections. I won't see you guys again until Thursday, but on Thursday we kind of have, I call it a double block because it's just twice as long. So we'll get 4 and 5 done next day, and then 6 and 7 will be next week. So at the end of next week, we'll likely be done Unit 4. It's going to take us about 2 weeks. There's 7 lessons, which is a bit longer. I think I might do 2 of the following. Anyways, so there you go. That's kind of a timeline for us. We'll be done this Unit 4 at the end of next week. That's kind of my goal. That leaves Unit 5, which is kind of short, and I hope maybe to get 5 and 6 done before the break. I know what you guys are thinking. Mr. Borden, you're thinking all the way to December break. It's really not that far. I mean, today's the 15th. You have about a month of school left before winter break. So yeah, that's kind of where we're at. 4 and 5 will get done for sure. I don't want to leave 6 like before and after the break, so I might push things a little bit to get 6 done before the break, and that'll leave 7 and 8 for after, which are 8's really quick and easy. 7's a bit longer, but nothing terribly difficult. So there you go. I'm going to leave you guys with that. You guys should definitely finish the first 5 pages of the learning guide. There's 2 quizzes to try here as well for units 1 and 2, or lessons 1 and 2, and lesson 3. So you should go through those over the next couple days. And I will see you guys on Thursday, bright and early, for the next section. So have a great afternoon. Try to avoid the rain if you can, and we'll see you guys on Thursday. Thanks.